Hello, physical geology students. This is the second video for the Wednesday lecture, and for July the 15th. And what we're going to talk about next is the water cycle, it's also called the hydrologic cycle. There's a lot of information I'm going to cover here, but let me first open up this picture so you can see it better. This is straight out of your textbook, and it looks kind of complicated, but it's all based on common sense and basic laws of physics and chemistry. But I'm going to cover the basics here. Now, when you study hydrology, this is the first thing you're going to study at UT. If you're studying for a hydrology degree, is the water cycle or the hydrologic cycle. First thing you want to bear in mind is that 97% of Earth's water is in the oceans. That means only 3% of Earth's water is fresh water. Okay? So, the average water molecule is going to begin its journey in the oceans. And what these blue arrows are showing is how water moves from one part of the earth to another part of the earth through and then the water is going to return back into the ocean. This laptop, it gets hot, and so I put it in my knees. It gets hot, so I got to move this around. But anyway, so let's start our journey right here in the oceans, and imagine that the sun is beating down on the oceans. That is going to cause the first part of the hydrologic cycle, which is evaporation. Evaporation is when liquid water changes into water vapor, and that rising warm moist air formed by evaporation is what meteorologists call a low pressure cell. So a low pressure cell forms, warm moist air rises higher into the atmosphere. And I'm sure you know that the higher the altitude is, the colder it gets, right? So as that warm moist air rises, that air is going to start to cool down. And in order to understand what happens next, you need to remember one simple fact, and that is warm air can hold more moisture than cold air. I'll repeat that. Warm air can hold more moisture than cold air. So as this air mass rises, its ability to hold water gets lower and lower and lower. And that results in increased humidity. What is humidity? Well, humidity is a function of how much moisture air can hold, right? So, if the air is getting colder, it can't hold as much moisture. So, there's another way of measuring that. It's called the relative humidity. I don't know if you've heard about that. Relative humidity. Relative humidity goes from 0 to 100%. When a mass of air is holding has a relative humidity of 50%, that means that air mass is holding half as much water as it can possibly hold. And when it's 75%, that means there's only 25% away from 100. 100 means that the air can't hold any more moisture. Another way of saying it is, as that warm, moist air rises, relative humidity gets to 100%. That means the air can't hold another drop of water. And that causes the next step, condensation. Condensation is so we go from evaporation to condensation, is when water vapor changes back into liquid water. Now, this liquid water contains water droplets that are extremely small. You can fit 1 million of these little water droplets onto the head of a pin. That's how small they are. And that's what we see as clouds. So how so we go from evaporation to condensation. How do we get rain then? How do we get precipitation? Precipitation means rain, snow, or hail. But how do we get to that point from condensation to precipitation? Well, these tiny little water droplets are so small that they can't fall to the ground. There's not enough mass for them to fall to the ground. So you need something to attract these water droplets like a magnet and bring them together to make an honest to goodness raindrop. And the things you need are what we call condensation nuclei. This is what meteorologists, people who study weather, call. What is condensation nuclei? Condensation nuclei are salt and dust in the air, and the salt and the dust in the air attracts water like a magnet. And then if you get millions of these water droplets collect onto a piece of dust or salt, it's going to get heavy enough so it falls down as precipitation. You ever wonder why people salt the clouds to get rain? All they're doing is they're adding condensation nuclei so those water droplets will collect so it'll be heavy enough so they can come down. So we started off with evaporation and we go to condensation, then precipitation. What happens next? Well, the rain falls onto the land, or snow, but we'll just say rain. So the rain falls onto the land. Now, the first thing that happens is called infiltration. What is infiltration? That means that the ground starts to absorb the water like a sponge. Then what happens is the soil starts to get filled with water until it can no longer hold any more water. But before that happens, before it can't hold any more water, something else happens, and that is called transpiration. I'll spell that for you. Okay, transpiration. Transpiration means that as this water infiltrates into the ground, the plants some are going to remove some of this water through their root systems and directly re-release that water back into the atmosphere. So some of that water that infiltrates will get taken up by plants through a process called transpiration, but eventually the soil can't hold any more water. Then what happens, do you think? You don't need to be a scientist to figure that out. What happens when the soil can't hold any more water? Then the water is going to run off into the ground and fill all the creeks and streams and rivers. We know that rivers flow downhill, don't we? Where do most rivers end up? In the ocean. So the water is going to run off back into the ocean. This whole cycle, ladies and gentlemen, imagine a water molecule beginning its journey here, going through evaporation, condensation, precipitation, infiltration, some transpiration, and then runoff. It might take a water molecule 2,000 years to make this journey. So maybe at the time that during Christ, when Christ was alive, the water was here, and then it took 2,000 years to return back to the oceans. It could take that long. It could take less, or it could take more time. But the water goes from one place to the other, from the atmosphere to the land, back into the oceans. That's called the hydrologic cycle. Okay, evapotranspiration. You can also say some people call it transpiration, other people call it evapotranspiration. Watch all the videos here. Click on that. I'm not gonna. It takes me a long time to upload these videos on YouTube, so I'm not gonna play this. But you play it yourself, and there'll be some stuff there that'll help you. Next thing, we want to talk about is we're going to start talking about rivers and streams and creeks, but instead of, and brooks, which are all running water. But instead of saying that every time, rivers, streams, creeks, and brooks, I'm just going to say uh, um, creeks or rivers. Um, First thing we need to know is what is a drainage basin? A drainage basin. Well, here you can see a river, and you got all these little creeks flowing into this river. So this dashed line here, everything inside of this dashed line is called the drainage basin for this river. What's that mean? That means if it rains anywhere inside of this area, that water is going to end up in this river. Every river or creek has a drainage basin, an area that contributes flow into that particular river. For example, what is the biggest river in the United States? The Mississippi River. Let's take a look at the drainage basin for the Mississippi River. This, ladies and gentlemen, is the drainage basin for the Mississippi River. All of this area in yellow. Any rainfall or snow or hail, that water is gonna end up in the Mississippi River. And the Mississippi River, which begins its journey up here in Minnesota, ends its journey all the way down in New Orleans and flows into the Gulf of Mexico. So all these other rivers here, the Red River, the Arkansas River, these rivers are all tributaries of the Mississippi. They flow into the Mississippi. And so they're in the drainage basin of the Mississippi River. Every river has its drainage basin. Tennessee River has a small drainage basin. Stinking Creek has a very tiny drainage basin. The drainage basin is the area that contributes flow to a particular river. What is a drainage divide then? Drainage divide. Well, a drainage divide separates water flowing into one river to water flowing into other rivers. For example, and it's always high ground. If you think about it, high ground. Let's see, I get this right in the camera. High ground. If you got a river, on both sides of the river, you're going to have. This is hard to do. Let's see. So on both sides of a river, you got high ground, right? You got ridges. Your ridges are your drainage basin, or your drainage divides. So here's a drainage divide. Here's a drainage divide. That high ground. Okay. So where's the high ground here on the edge of the Mississippi River drainage basin? It's the Rocky Mountains. It's the drainage divide. So that any rainfall that falls east of the Rocky Mountains is going to end up in the Mississippi. Any rainfall that falls west of the Rocky Mountains is going to end up in the Pacific Ocean. Rainfall that falls east, this divide, what is it? It's the Appalachians. So any rainfall that falls east of the Appalachians is going to end up in the Atlantic Ocean. But if it falls within this yellow area, the drainage basin of the Mississippi River, it's going to flow into the Mississippi through its tributaries. So a tributary is a river that flows into a bigger river, such as the Arkansas River being a river flowing into the Mississippi. Now, what is a perennial stream and an ephemeral stream? And when we say stream, it also means rivers and creeks. But what is a perennial stream? A perennial stream is a river that flows all year long during um, dry times, during wet times, whereas an ephemeral stream is ephemeral stream is one that only flows during um, high rainfall or during wet seasons, and it's dry most of the year. East of the Mississippi, streams are perennial; they flow all year long. Why do our streams flow all year long, whereas many of the streams out west they only flow a couple months a year, in some cases only a couple days a year? The reason's simple. East of the Mississippi, we have a higher groundwater table. The water underground is closer to the surface, so that when it becomes dry, groundwater will flow into the rivers and make up for that lack of rainfall. But out west, the water table, the level of the groundwater is way deeper underground. So if it doesn't rain, those creeks will just be dry. You'll just have dry gullies there. They're out west, and so we have perennial streams at back east, and we have ephemeral streams out west, mostly in the United States. Okay, I'm gonna skip through some of this stuff. If I don't cover it, it's not gonna be on the test because we have so much ground to cover, and I don't want you to miss some of the other chapters. But please don't forget, 97% of the water on planet Earth is salt water. 3% of our planet's water is fresh water. Most of our fresh water is stored in ice, about 2%. Therefore, only about 1% of the water on planet Earth is liquid fresh water. And of that 1% of that liquid fresh water, there's 30 to 50 times more water underground in groundwater than all of the rivers and lakes combined. If you want to hear those numbers again, just rewind it and hear it. But we talked about water laws and water rights. So um, water rights uh, have to when you buy real estate, you also buy mineral rights. You own the minerals under the ground. I mean, and you own oil and natural gas. But you also you own the rights to the water on your land. If it's a creek, if it's groundwater, you own it. But our water laws have changed, and we'll talk more about that when we get to the groundwater part. Back in the days when we were 13 colonies, we had British water law, which states that when you buy a piece of property, you own the surface water, that means the rivers and lakes that your property is on, and you also own the groundwater. But we found out that that doesn't work very well. So, for 47 states in the Union, we've amended British water law to state that you own the water on your property and you can use it as you wish as long as you do not negatively affect your neighbor. I think that's an improvement over British water law. I think Maine still has British water law. California has a different type of water law that um, is based on the war with Mexico, and so the old Spanish families, when they signed the treaty ceding California to the United States, they got to keep some of their water rights, and these have been passed down. Of course, those Spanish families are almost all gone, but they've been passed down and sold. So it's kind of complicated things. Let's see here. So we talked about some of these water laws. So let's talk a little bit more about streams. Okay, I'm going to draw you a little picture to show you some anatomy of any stream. And when I say stream, I also mean a river. Let me get you a picture here. Okay, I'm going to draw you a picture. And this is a side view. And so the water is inside of the channel flowing out of this picture, if you can imagine that. So that this is the ground up here. So I'll put a little tree here. So there's a bird up here. So the water's flowing out in this channel. This is what we call the river channel. The river channel. And let me draw you another picture here. I'm going to give you a wider view to show you what the river floodplain is. Floodplain. So here's our river channel. The water's flowing out of it. These two little bumps here on the side of the river, these are called levees. Levees. These two bumps are levees, river levees. Then you got this flat ground here on both sides of the river. These, I'll just write FP. These are the floodplain of the river. These flat areas are the floodplain. And then you get up to the highlands, the mountains over here. And these are your river divides. So the water is going to flow in. Any rainfall that falls on these slopes is going to get into the river. Any rainfall that falls on the other side is going to go into some other river. So you got a levees, a river channel, and a floodplain. Most people when they think of a river, they think of the river channel, the water flowing through the valley. They think of that as the river. But the floodplain, every time there's a flood, what happens is when it rains really hard, the water is going to overtop the levees and flood the floodplain. And it's going to deposit clay here and silt. The sand and the gravel is going to stay in the river channel because it's heavier. But the lighter stuff, the silt and the clay, will get deposited onto the floodplain. So obviously you know now that you've studied a little geology that the floodplain is going to get preserved as siltstone and shale, right? Whereas the river channel is going to be sand and gravel, rounded gravel. It'll make conglomerates and sandstones. But the floodplain, a lot of people don't think of that as being part of the river, but it is part of the river. It's just not used as often. It's only used during a flood, and so that the excess water from rainfall is stored on the floodplain, is absorbed by the floodplain during a flood. But it's part of the river. And here's the bottom of the river. The very bottom of the river, it can be seen here, and that's called the Thalweg. Thalweg. Okay, so here's your river channel. Here's your levees. Here's your floodplain. Now, why are there these bumps on both sides of the river channel? Because every time a river overtops its banks, the coarser stuff, the coarser sand, won't travel as far and gets dumped out on these levees. So with time, these levees grow, don't they? They grow. Okay. I'm drawing another picture here. 90% of rivers, 90% of rivers are what we call. Let me make a note here. Okay, there's two kinds of rivers, and I'm going to spell them out for you here. Oh Lord. Actually, I don't. I use some other program here. This program just sucks. Okay. Okay. So there's two kinds of rivers. You have meandering ones, and you have braided ones. Okay, meandering and braided. 90% of the rivers in the world are meandering. Only 10% are braided. If you grew up east of the Mississippi River, every river you've seen is a meandering river, a meandering stream. Now, what's that mean? Well, let's take a look. If you've ever looked at a river, this is from above, looking down from an airplane, you might notice that no river flows in a straight line. It curves back and forth. And these curves are called meanders. Again, this is looking from above. This is what a river looks like. Now let's look at a river from the side view again, not from the above view, not from the aerial view. Let's look at it from the side again. Once again, we have our two little bumps on both sides of the river channel. And then you have the floodplains over here, right? Okay, now this is called the river channel. We're going to take a closer look at this river channel, what a meandering river channel looks like. Let's draw in some detail here. So I'm going to draw two pictures. Here's your meandering river from above. And what I'm going to do now is I'm going to take a look at the river on this line, going from X to Y. So I'm going to draw in the river. Here's your river. Okay. How does the river... Now I'm going to look at this river channel right here. So what it's going to look like is that. Notice that for a meandering river, the river channel is not a U. It's steep on one end, and that's at the end, at these meanders. See where these meanders are? It's steep there. And over here on the inner part of the bend, it's more gentle. And here's your water flowing through this river channel. This part of the riverbank right here, on the outer end of this bend, is called the cut bank. This part here, on the inner part of the bend, is called the point bar. Point bar. Since the river is flowing through this asymmetrical channel, it's steeper here. The velocity of the water is going to be higher here at the cut bank, eroding the cut bank. That's why we call it a cut bank. So the river is going to grow this way. It's going to grow out from the cut banks. In other words, it's going to grow like this with time. Where would you want to buy your real estate, by the way? On the point bar, right? Where there's less erosion. Because on any sediment that's eroded on a cut bank, like this cut bank here, gets deposited at the next point bar here. So this sediment accumulates from along these point bars, and it erodes along these cut banks. The sediment from this cut bank here will be deposited at the next point bar, and this cut bank here will contribute sediment to this point bar. So, when a river is young, it's going to be straighter, isn't it? There's not going to be too many bends in it. But what happens as a river gets older? It becomes more and more meandering, right? As the river gets older, it becomes more meandering. So is this an old? This would be an old age river, wouldn't it? Where it's got a lot of curves in it. It's an old age river. It's been around for a while. This is a younger river. So rivers age just like human beings do. They go through youth to middle age to old age. Let me talk a little bit about the characteristics of rivers as they age. This was first figured out in the 1800s, by the way. Um, Young rivers flow relatively straight, and they have rapids and waterfalls. Middle-aged rivers curve more. They no longer have rapids and waterfalls. As they cut from side to side, they make a wider floodplain. So the floodplain becomes wider. As the river continues to grow, it cuts out a wider and wider floodplain. This whole area here would be the floodplain in between these dashed lines. This one has a more narrow floodplain. So as the river ages, it gets a wider floodplain. And an old age river, you're going to have a very meandering river and a very wide floodplain. Old age rivers also have um, taller levees because the levees grow over time. The older the river is, the taller those levees are. You ever notice the farmers, every time it rains a lot, what's the first thing they do? They put sandbags on the levees so to hold the river in its channel. So here's a young river. Uh, Maybe it's just in its teenage years here. It's got rapids and waterfalls, and it's got pimples all over its face and thinks about girls all the time. Now you're middle age. Maybe you've been through divorce, and you're still interested in women, and your body's okay, but your hair's starting to thin out. And now you're an old age. Now you're in the nursing home. Now you got a wide floodplain, tall levees, very meandering, and maybe if you have a wife, you can say, "By God, I'm still here, baby." I don't know. That's ridiculous. My jokes are getting bad. I'm sorry. It's getting late. So, yeah, it's too late. I'll finish. I'll do another video tomorrow.